Good day to you. This is Anagalactic. This is a rebasis of science itself. This is no longer a theoretical proposition. For 2,500 years, dating from Euclid, science is 100% constructed on the line invented by Euclid because he axiomatized the linear system. He did so correctly given his first proposition. The universe is made of space. There's no concept of anything whatsoever in science except for linear spatial separation. That is an extraordinary statement. Can you define space? You might, or you might think that you can, or you might try. There is only one way to define space, and that has never been discovered until 2022. If you come up with a theory, it means you've failed. The only way to begin axiomatizing universal space is with a spatial metric. Okay? Euclid began with the point because he had to axiomatize the point in order to make sense out of the line. It wasn't until James Clerk Maxwell, Max Planck, Hermann Minkowski, and Albert Einstein that the modern age of physics began, and it hit us right in the solar plexus. The methods and tools which were developed in mathematics in order to cope with this incredible new horizon of spatial perception resulted in three amazing tools, linear algebra tools. Our first, sine-cosine, sometimes called CIS for short, two functions. Science only uses one componency space, but nobody, to the best of my knowledge, has ever correlated those names. The point, the linear number, the quantum, one componency space. The second tool, which was developed in the 19th century approximately, was the complex number system. The complex number system is a hybrid two-componency system utilizing an amazing trick called the square root of -1. In order to make complex numbers work with the linear number system, which are the computable numbers, a function had to be invented that would translate complex numbers, which are two-component numbers that make a system of numbers, each of which has two components, that must be translatable to linear logic. And there's only one right way to do it. It's called conjugate algebra. This is an extension to the mathematics system. It is the only system used in science right now, and that is a magnificent blight. The calculus system is what destroyed science. You could put all the writings of science in one room, and in an adjacent room put all the books that have ever been written on calculus, complex numbers, and sine cosine, and I would guess that it would be commensurable. So, The metricization of space is linear. It's based on the point. And the point is a 0D object. That's Euclid. And that's now. 0D. You know what that means? No lines. So if you have no lines, and all you have is a point, then you have something to which we have given a name. Nullity. Null. Nil. Nothing. Nothing. So the axiomatic basis of the universe to this day is nothingness. The glaring defect of zero. The basis of the number system we use is zero, you understand. Zero is always there. You can't do anything without zero. But it's null? It's just the absence? Well, what is it then? There is a definition that makes sense. And this is the one that Euclid arrived at, and we found it useful ever since. The reason why the null point at the center of the linear system, called zero, the reason that that has value is because it represents spatial position. 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 You might ask, if you're clever, position in what? What is the function of the point? Those dimensionless points, which are on the one-dimensional line, are numbers. The linear number system has a grievous flaw. It's not just zero, which is a derivative number on the line. I proved that in 2022, and we're going to cover that today. This is going to be a long lecture. So take a break now if you want to. Put this on pause. Get yourself some cool or warm refreshments. It results in the singularity at the center of the black hole. It results in the singularity at the beginning of the universe. These maniacs believe that they're able to formulate now. They're living in a fantasy world. With calculus, sine, cosine, and complexity, you will never get out. You'll never get out of that system, and you'll never get any answers. Not to anything in cosmology. You'll never understand galaxies. You'll never understand the black hole. You'll never understand the universe. And moreover, you'll never understand the building blocks. You'll always be locked in the quantum paradox. They are. You want to follow them? They're going to hell. Okay? This is the introduction to the bootstrap theorem, which I developed in 2022. Spatial metricization. Let's stop there. What are we talking about? Why are we what is this big word metricization? Do you know what a metric is? Do you know the meaning of a metric in space? It's how you measure space. Do you know how we measure space? You'd better, but I'll tell you the answer. So that if I give you a quiz later, you'll get it right. How do we measure space? LNS. Linear number system metricization. Okay, what's that? LSS. Linear. Spatial. Separation. The index of the metric of the line is 1. So now you know the role of 1 in the metric. It's the index of linear spatial separation is 1. And the distance from 0 to 1 cannot be divided. The desperate effort in the 19th century to make the line emulate continuity was disastrous. Utterly disastrous. For a very simple, logical reason, which these men either were too stupid to notice, or worse, they purposely disregarded the idiocy of what they were trying to do. Because the entire basis of Euclidean geometry, resulting in the computable number system represented on the line, is entirely due to quantization of the line. That means quantization of the space. That means quantization of the linear spatial system. Quantization. Those are called numbers, right? The standard model of particle physics is capitalized on that error, and they have an absolutely psychotic axiomatization of the particle, where those dunderheads insist that the line is continuous because of the calculus. It's the calculus that does the cheating to pretend that linear space can be made continuous. It cannot be, because if you made it continuous, you'd have no numbers. The entire basis of the number system used in science is the quantization of the line to the Euclidean point, which is null. All the numbers are null. Until you introduce the metric of 1, the distance, linear spatial separation from 0 to 1. Cantor said, lying in his teeth, for which I believe he paid, that the distance from 0 to 1 can be infinitely divided. No, it can't be infinitely divided. Idiots! So that's the fundamental lie of algebra. The fundamental theorem submerges beneath this fundamental theorem. You have built a lie. And that's why you have the quantum paradox. It's because of your stupidity with your number system. Nobody's been able to realize that the line has a number system. Well, then the universe is lying to us. You want to leave it at that? Science is willing to do so. That's the state of science today. That the universe has lied to us. It's everywhere on the internet. In presentations of physics, of science, of mathematics, everywhere. Taken for granted. It's a fantasy world. The quantum cybernetic projection of the universe is on every lip now. Complete lunacy. Parallel universes. I could give lectures just on the insanity to give you example after example of these top-notch presenters on YouTube. They're also in the textbooks and universities and everywhere. Top-level physics, they talk about pure psychosis. They're comfortable with it. They have to be. They can't find their way out of the labyrinth. Okay. So now you understand the dilemma that science is in. It's using the wrong number system. What I am going to show you now is that that was necessary because we had to develop the linear number system first. For one reason, and one reason only, to get the computable numbers. On a computer, we can define, with feedback from the universe herself, just what our numbers are capable of, how we can represent them, so that they perform mathematically correctly on a computer. The division by zero error must be captured. If you send a division by zero instruction to the CPU, it freezes the CPU. You're going to have to unplug and plug in. That's called a reboot, because your system is frozen, because you violated the law of the universe. And so your computers are all liars. We've programmed our computers to lie. That is unnecessary, and I'm going to fix it right now. We're going to fix the number system so that it works. It doesn't work. You must realize that. You can't have division by zero, you idiots. And all of your numbers represent a pure illusion. It has been useful to us. And with the development of the calculus, it's caused untold miracles to unfold on Earth. That induces a religious response in every human. Don't ever believe a man when he says he's an atheist. He's a liar. There's no such thing as an atheist. And any man, even Richard Dawkins, whom I respect as a human, although if we were friends, I'd have a serious talk with Richard about his lunacy. In science, you're not supposed to talk about God. I agree with that. But when a man violates that principle, which is commonsensical, of course you don't talk about religion and science, you jackass. Well, Richard Dawkins has signed himself up to be the chief jackass. And he goes right out and he's been writing books, and he's a very, very popular presenter. Because he carries the current lunacy to its religious conclusion. He says, not only is there no such thing as a designer, completely illogical statement, but he goes out of his way to make sure that you know that if you want to be a scientist, you're an atheist. Science is atheistic. Is it? Is it really? Is that right, Richard? You won't pay at my hands, Richard, but you will pay for that. You will pay for that. The universe has already decided. You can't get away with saying that, you maniac. You misguider of youth. You seriously demented. Yes, there is a designer. That's been proved by science. So, let's get going with our bootstrap sequence. I will be consulting this as we go along. You might want to take another break, get yourself some refreshments, put my pretty face on hold, and then get your ass back here to learn about the truth. Okay? That's the way it's going to be from now on. They don't call me the professor for nothing. So, we need spatial metricization, correct? How do we do it now? 0 to 1, with all of our maniac physicists and mathematicians saying, oh, it's continuous from 0 to 1. No, it's not, you liar. Because that would destroy the whole system if it were continuous, wouldn't it? Yes, it would. So how do we get continuity into the system? Why would we need continuity in the system? Well, you could ask Cantor, because he sure tried hard enough to make it continuous. You could ask Hilbert. No, he's dead, but if you could ask Hilbert, you consult his writings, you'll find out why he insisted that the line can be made continuous. Can it? No. So why do they say that it's continuous? They have no choice. And so they pretend that it's continuous, and then wonder why they have a quantum paradox. So, our linear system has an innate restriction. It's only capable of producing the linear numbers, which are computable. and our computers can prove that to us, and that has been done. All the work in computer science was for one reason only: to validate that our number system works. It does, if you use calculus to shave off the corners. That works for technology so well that men are inadvertently convinced of divine oversight in both senses, that the designer, whom they insist does not exist, invented mathematics for us. But the way they say it is to make sure that the designer gets no credit for it. They say it's a cuckoo clock. This is equivalent to locking the supermassive black hole in a zoo so everybody can throw rocks at it. The defamation of logic. So how do we metricize space other than with the line? Because the line has no continuity. It's quantized by nature. Nature quantizes the line, so we have numbers. What are those numbers for? If you say it's for technology, you lose, and you can turn this off and go back to your YouTube and back to your rubber ducky. The reason we have to have continuity in the number system is because the universe is continuous. It's not quantized. Our number system is quantized, the universe is continuous. That has been proved. So, do you see a problem there? You'd better. How are we going to compute gravity? Well, you may know that there have been two major formulations of gravity, but I'm not going to go into that now. I'm merely addressing your attention to the phenomenon of gravity. Gravity. Yes, gravity. What kind of a function is that in real space? Here's a multiple choice question for you. Is gravity linear or is gravity spherical? Well, even a school child knows that it's spherical. So where does that leave your linear numbers? Helpless. Helpless. No way to understand either the sphere or the circle. And neither one of them is understood. And I've given lectures on that. So what do we need then? If we could get it, which all the top scientists assume that this cannot be had. There is no solution. You're stuck with linear algebra forever and ever, whether it works or not. Too bad. Because it works for the government. And if it works for the government, end of story. It works for the government. We're not affiliated with any government. We're free men. We're free scientists. We're not paid by the industry. We're not beholden to the government. We don't kiss anybody's ass or any holy cow's ass. We consult the universe directly, don't we? You will now. You're with me now. So, what is the correct metricization of space? The first fact to which all of my hot air has been leading right now, the metricization of space must be using linear numbers because they're computable. So we're back in the labyrinth, aren't we? That's the state of science today. We have to use the linear numbers. For everything we do, that is a fact, because they're computable. All right. You may ask, why is computability so important? Do some homework and find out. I can't go into that now, but it's been proved. We cannot leave the linear number system. Our attempt to do so was with complex numbers. And that's a most interesting system, which I cannot go into now, but I have lectures on the complex number system that fully explain why it's so miraculous. You must understand that the natural number system is no longer used. Not even the so-called real number system, the gift of Cantor. The continuous form of the line is the real line. The real line is the continuous line. You know it's pseudo-continuous because you can't get around quantization. Linear numbers are quantized on the line. That's tautological. All of this has been rigorously proved, so you must accept it. I do. And that was my major challenge when I discovered spherical geometry. So that's what we're going to define right now, is the correct number system for modern physics. Nothing less than that. Because gravity is spherical. Can you think of anything else in physics that's spherical? You might. For instance, in astronomy, what up in the sky is spherical? Well, you could begin with Earth. That's spherical. Do you know why? Do you know why the Earth is a sphere? All right, we look up in the sky. The first thing we see is the sun. Is that a sphere? Yes. Why is that a sphere? Then you look at the moon. It's a sphere. Why? And what is the path of the moon around the Earth? It's a circle. Why? Gravity. Correct? As part of the answer, there's a force. Gravity is a force. Gravity is a force. Right? Absolutely right. So what else in nature is spherical? Let's go all the way to the edge. Is the universe spherical? Every child knows that it is. Common sense says that it is. The mathematicians say no, it's not. It's saddle-shaped, or it's involute, or it's hyperbolic. They're liars. They're speaking from the point of view of someone lost in a labyrinth. And they're trying to understand their labyrinth, but it's made of lines. And they can't see continuity. So what's the relationship here between our number system and what we see in the universe? Well, our number system is quantized, but the universe is not. It's that simple. So what do you learn from that? Sphericity is continuous. The manifestation of sphericity and circularity, both in the solar system and all the way to the edge, is 100% continuity, no quantization. There is no quantization in the universe. Nothing is quantized. There's a footnote, though, and this leads us into subatomic physics. There's a sphere at the center of all things. What we call matter is based on spherical geometry. We've gotten down to the Bohr atom. That's considered to be the building block of the universe, and you can consult the periodic table to see the magnificent artwork of the designer in creating the atomic system. Approximately 100 elements exist, all based on the proton, and the proton is a quantum. So the proton, by our own linear definition, is a number. The proton, because it has a point center and is particulate, which means it can't be divided, it's a unit, that means it's a number. So that's why we have atomic numbers. The number of protons is the universe's idea of counting. And is a number a point? Yes, according to Euclid, it has to be. A number is always a point. But a proton either is a point or it's not a point. Which is it? Which is it? Is the proton a point or not. Then we go to the electron, and then we go to the photon. That's the sequence we're going to cover, so that you understand the basis of the universe's idea of numbers and geometry and reality, not your professors, who are locked in a labyrinth and they can't get out. We're going to get out right now by identifying a new number system that the universe uses. This is what I discovered. So, spatial metricization is quantization using the linear number system. Correct? So the universe as space, we think, is based on linear separation. That's the only metric we have. That's why we measure the distance to a star on a straight line. That's correct. The photon goes on an impossibly straight line from the star to your eye. An impossibly straight line. It goes directly on a straight line covering any number of light years, bullet straight, right from that atom in the star to the atom in your eye. Straight to it. Impossible, right? That's the quantum paradox right there. Now, Albert Einstein told us the universe consists of time. Isn't that an interesting concept? This has led to the most harebrained pseudo-philosophy ever heard from the poisoned mind of man in upper echelon physics and popular or popularized mathematics and physics. Time is up for grabs. Everyone wants to fantasize about time now. Time travel. The twins paradox. Time dilation. Paradoxes after paradox after paradox after paradox. Focusing on time, where we have intuited as a collectivity of scientists that the answer has to be found in time, because Albert Einstein pointed us right at time. Time! Can you metricize time? You have to now, because Albert Einstein proved that there is a direct relationship between space and time. That has been proved. What I've brought out are the details of his discovery, which you never hear because the essence of his discovery is geometric. And whether Einstein fully understood the nature of his discovery or not, nobody knows, because nobody can probe Einstein's mind. But I'm willing to at least guess, based on what I know of Einstein, his attitude towards the universe, towards reality, towards the designer whom he believed in, because he's a scientist and not a fake. He had to see it somehow. But unfortunately, Albert Einstein, being the amateur that he was, not really intimately involved in the deepest things of science, because nobody can be, because they're stuck with a linear algebra system and though they can't formulate anything correctly. He tried to penetrate that barrier, and he was successful. The only tragedy in Einstein's discovery of relativity, the Einstein field equation, special and general relativity, the formulation of spacetime, which he got from Hermann Minkowski, but he perfected it, and he created a linear solution for gravity. A linear solution for gravity. You know it's wrong. We have to identify where it fails. It does fail, because where's the continuity? You see, the continuity is introduced into the system by virtue of time. When he included time in the space metric, Yeah, we're back to the word metric again. Do you know what the metric is of space-time? I've given lectures on this, but it's important for you to try to face this, and don't be afraid. Don't think that these men are above you. They're not. They're just like you and me. It's just that they're blind, and we don't want to be blind. The whole purpose of science is to relieve blindness. So what did he do? He linearized time. He forced it to be linear. And by doing so, he created a 4-line system that cannot work. But since it's geometrically sound, according to the linear axiomatization of space, that everything measurable has to be on a line, you understand that's the basis of science. If you want to measure something, it has to be on a line. Well, that fails, because the quantum is not on a line. It's off the line. That's why there's a paradox. We cannot measure off the line. We fake it with calculus. That doesn't work, because you're quantizing everything. Albert quantized time. That was his mistake. He was forced to it by the system. So it's a miracle. I believe nothing short of a miracle, in line with several other miraculous breakthroughs. It's a miracle that he was able to discover the relationship between time and space. Do you know how to define that relationship? You must be able to do so. What's your answer? What is the relationship, geometrically, between space and time? They're orthogonal. They are at right angles. They're perpendicular to each other. Well, since space has to be linearized, it is. In a 3-line system, that's volume space, 3 lines, a grid. Albert took that grid and added a 4th orthogonal line, orthogonal to space. But space is quantized. Therefore, time has to be quantized as well. And you know what quantization means? Linearized to a 1-component number. And that is what is involved in 4D geometry, is that time is linearized so that it has an identical characteristic with space. What is the identity between space and time that allowed them to be correlated? It used to be assumed that they were incommensurable. Einstein broke the mold and shows that they are commensurable, directly relatable using linear mathematics. And he discovered the secret of relating time to space within the confines of our hideous grid system. That enables spaceflight, so it's no mean feat. Without relativity, there would be no spaceflight. We cannot control craft in outer space without taking into account special relativity conversions and general relativity conversions for time dilation. It's called dilation because of a relativistic effect. That is an illusion. There is no such thing as time dilation. Time is continuous. That means it's constant. And it doesn't make any difference what anybody else says about time. Time is continuous. That means it's not linear. It's not linear. And so we cannot measure time. If you want to measure time, you have to go to Einstein's field equation. And there you will find time shoehorned into the three-line grid system of quantization. But you've maligned time, and you missed the truth, and you ruined everything. Now, Einstein gets credit for what he discovered, and I'm not taking away from what Einstein discovered. It's miraculous. We would not be able to travel in space without relativity. Well, you see, that arouses the worship instinct in humans. To worship the number system. It means that it's infallible. Infallible, is it? We just proved that it's the definition of fallibility. So what's the way out of this trap? I discovered the solution to all of these paradoxes in 2022. So, why is time continuous? Let me ask you this. Is space continuous? That's difficult to say right off the bat. You would have to prove your answer one way or the other. So is space continuous or not? If you want to measure the distance to stars, your answer has to be no. It's not continuous, or you can't measure. If it's continuous, you can't measure it. It has to be quantizable. And so we get the distance to the star in light years. Light years? Really? That doesn't sound like a one-component number. It's not. Light speed is a two-component number. And the measure of distance to a star is also a two-component number. It has to be. And that's why it's called light speed. Speed is not a one-component number. It's a two-component number. Light speed is a two-component number. So, the problem we're facing is we're dealing with a universe that's continuous with a number system that's anti-continuous. Those don't match. So what do we do about it? I just gave you the clue, so you may be able to guess. Well, what we need is a two-component number system. And it's magic what happens if you're able to devise a two-component number system. We tried with complex numbers, which are miraculous, because it's a pseudo-answer. It's a partial, you could say it's a partial derivative of the right solution. That's actually true. Because you're using calculus to get your answers, you've admitted defeat. Because once you use the calculus, you lose. Because the calculus has only one purpose. It's to get a one-component number out of two-component space. Where space is being used geometrically now. It could be the space of time, or it could be the space of space. And if that sounds funny to you, I suggest you wipe the grin off your face. Okay? So motion is where we get the concept of time. Think about that for a second. Does that sound rational? Does that sound true? Could I prove that? Oh, I already have proved it. But it's actually very well known. The concept of time is not derived from space. The concept of time is derived from motion. Only motion yields the concept of time. It's the aspect of the universe that is non-spatial. It's the non-spatial. That means, I think you know what that means. Albert showed that the structure of the universe, the fabric of the universe, is space-time. That is correct. That's absolutely correct. So not only did he get the concept of space-time, which is correct, but he was able to show the relationship between time and space, that they are orthogonal. I've proved that Einstein got that right, but by a proof that nobody knows yet. So I'm going to share it with you now. Get yourself something warm to drink or something cold to drink, because this is going to be a long lecture. Okay? You don't have to watch this in one sitting. I have to deliver it in one sitting in order to give you the continuity necessary to grasp the result. Okay, so that's very important in a science presentation. Continuity. So be sure, if you do break this up into visualizable segments so it doesn't grow tedious, if you feel weary, turn this off and come back to it later. But don't wait too long, okay? So we now have a concept of space and of time, and since time is involved, motion. Let's go on. So we know what the metricization of space is now. It's quantized on a one-component linear system. All right, you got that. We need to remetricize space so we can include time. Well, there's only one way to do that because they're two different data types. Time is not measured in spatial coordinates. Time is measured another way, and nobody's been able to figure out how to do that. I'm going to show you the way to do that. That's watertight, absolutely watertight. We started with the Euclidean point axiom. We now need to switch. So we need to go back to the beginning of the universe and reconstitute the universe according to the new number system which you and I are going to derive from original axiomatic principles that have so far eluded everybody, from Euclid to Einstein to Feynman to the present day. Nobody has ever seen their hand in front of their face with the obvious solution, and I'm just going to tell you that I know exactly why nobody else has been able to see this. Because I've had to go through the whole fish ladder sequence, one paradox after another, in sequence, not skipping a step, to get the correct axiomatic basis. So this is how it's done. We have to reconceptualize the point, because Einstein got that from Euclid, and that results in an inaccurate, ultimately useless definition of universal space. It's absolutely wrong because there's no continuity anywhere. Do you know how continuity is forced into the Einstein field equation? Hypercalculus. You may never have heard that term. Learn it. You want to learn about relativity, gravity, space-time? You need hypercalculus, which means you're stuck in their labyrinth forever and will never get out, and you'll never understand anything. That's the harsh fact. So, we need a spheric point axiom, not a linear point axiom. We're going to start over. There are no points, there are no lines, there is no nothing. But here's where Euclid comes in. We know from how the universe taught humanity how to make numbers that you must start with a line. And that's what we're going to do. And from the line, we're going to derive the correct axiomatic definition of the point, on which everything depends. And this is going to be a challenge to you, because it's going to defy everything that you were taught in school. That is where we're at with the quantum mechanical paradox, and that's where we're at with cosmology, and there are deep, magnificent repercussions on deep space astrophysics to describe macrospace objects, beginning at the galaxy and going all the way to the cosmic microwave background radiation, the supermassive black hole, and the quasar, and the formation of spiral galaxies and the formation of elliptical galaxies. None of this is understood because nobody has the right geometry. It has to be spherical. So we're going to get a spherical geometry, and from that we're going to find the spherical number system, a two-component number system. That's what we're going to do right now. Let's begin. Empty space. Empty your mind. You now have a blackboard in your mind with nothing in it. The universe before it has anything in it. This is called a geometric space. It is a metaspace. It's only in your mind. The object is to match the mind to reality. That's what we're going to do now. Empty space. Dink, make a point. We're not saying anything about it. But we're going to say that it's a Euclidean point for now, so that we know what it is. It's a dimensionless point, which means that it is a position. So we have one position, and that's the first step. One point in empty space. Now, we know what to do next according to Euclid. This must be followed in order to get the linear number system. We're now going to get it correctly. Here's how. There's the point. We have nothing else. Everything else is pure emptiness. All we have is a position. Now, we use Euclid. Make the line. We're going to do it slightly differently than the way Euclid did, because he had a directed end. When he created his point, it was with a view toward the line, because the line is what has the linear computable numbers. That's redundant. So what we're going to do is slightly different from Euclid, but it is Euclidean. We're going to make the line as two reflection rays. Now that might sound daunting. It's not. Watch. And do this with me. There's the point. Now, we're going to turn it into a line. Here's how we do it. Take your fingers and make these little pinchers. With 3 fingers, take your little pinchers and grab the point. And now we have a point that we're going to stretch linearly with a double ray. This is a polar reflective ray. You could do this, right? That's a ray. Where does it go? Infinity. So it begins at the point to which we do not assign a number. It's simply a position. That's a geometric term. It's a position. From this position, we can do this. That goes to positive linear infinity. Okay, that's obvious. Now, do the same thing but with the reflection. Pull, pull, pull. Now let it go. Where does it go? It goes to 2 infinities. Be more specific. It goes to 2 linear infinities. 2 linear infinities. How far away from each other are they? Difficult to answer, isn't it? Because if you just make a ray, it goes to infinity. Where does the other ray go? This goes to negative infinity, correct? All right, so that's all we have so far. That's step 2. We have now a polar infinite object. Polar means that it has a center, because the 2 infinities are equivalent, correct? There is no difference between this infinity and this infinity, but geometrically you can state the relationship between the 2 infinities. They're polar opposite linear infinities. So that's step 3. We now have 3 things. We have a center, which must be the center because these 2 infinities are exactly equivalent. And so the center is the point. And it has no numeric value. We're just doing geometry. All right. The next step is the key to the transformation, and it involves you being able to visualize the space in which you're working. Remember, this is only in your mind, but you can identify it with an empty universe in your mind, which now has a single object in it, a straight line. So they are now looking at a line. It has no mathematical value. It has no points except one. It has a center. And it also has two endpoints. Except they're strange, aren't they? Because it doesn't end in a point. But if it did end, it would be at a point. Correct? That is tautological because it's on a line, and a line is nothing except points. But we only have one point, the center. So what can we say about the two infinities? What's their relationship geometrically? The obvious answer is, the one that I gave, they're polar opposites on the line. So the two infinities have no existence except with respect to the center. So where is that line? It's in space, right? Okay. What's the shape of the space that the line is in? Is it linear? Here's where you need to stretch your mind, and you're going to have to take a step that every mathematician, geometer, and scientist has to take in a hypothesis step. You have to go out on a limb and make a statement that hasn't been proved yet, but you're asserting that you can prove it. Very interesting setup. It's called the hypothesis step in the scientific method. So this is the basis of science. We're now employing the axiomatic basis of science itself using the scientific process by declaring a hypothesis which we will then prove. So we begin with a statement which you may not be able to accept. That's why we need the proof step, so that you will accept it, because I am not the one saying it. Science is. The universe is. So what does the universe tell us about this straight line in empty space? Here's what it says, and this is our hypothetical statement that we will prove. That line is embedded in a sphere. Think about that. What's your reaction to that? Do you think that can be proved? Here's how to prove it. When you have the line and it's touching two infinities, is that indeed two infinities? No. Because the line has no meaning except inside of an embedding space. So now we're going to define universal space, so we have an actual space. Right now we have no space except the line. You know that Euclid called that an object that has length but no breadth. So that's linear spatial separation. That's what that's what Euclid meant by saying that it has length but no breadth. That is the definition of 1D. We are not making that definition, but we are going to derive it. We're going to derive Euclidean space. But first, we have to know from what are we deriving linear space, because this is not space. what is. We can prove what space is from the line. Because the line hits two infinities, it can be proved, and I'm going to prove it now, that that line is embedded in a sphere. And the hypothesis step is to say that the two infinities of the line are one infinity in spheric space. So now we have a sphere that is infinite. Does that sound like a reasonable definition of the universe? I say that is the only reasonable definition of the universe with which you must begin in order to make any progress on a rational, supportable basis. It has nothing to do with the line and nothing to do with quantization yet. But we're going to need to quantize the space to get numbers. That's what we're leading up to. That's a second theorem. This might be a healthy time for a break.